12, 19. Okay, so the objective today, what we're going to be doing is finding zeros from quadratics. Now that's a weird word, quadratics. Okay, finding zeros is going to make sense. It's going to make sense. Okay, quadratics are parabolas. Did you guys ever do the quadratic formula? Did you guys ever do the anybody? Okay, right. Yeah. Nice job, Damien. Very good. So, quadratic formula comes from solving parabolas. So, solving polynomials. So, if we're going to solve these, what we're really finding, we're going to be finding x-intercepts. I'm going to call those zeros. So I want to just give you a little itty-bitty graph here. And I want you to see this illustration so you know what's going on, okay? All right. Now we're not going to graph these. We will not graph any of these. We're just going to solve, but I want you to see what's going on. So if I had a parabola, it has two x-intercepts, right? The height, the actual height of these x-intercepts is 0. Does that make sense? That's why we call them zeros, because where the y is 0, we get these two values, all right? So most of the time, we should get two answers, right? You guys see that? We should get two answers because it's a parabola. So most of the time, we're going to get two answers. Okay, so in the example 1, what we have is two little mini equations, and these two little mini equations actually come from a picture like this. Again, we're not going to graph it. I just want you to know the answers we get will be x-intercepts. So we got two mini equations. We need two answers. We have two equations, so let's set it up as two equations. X plus 2 equals 0 and x minus 5 equals 0. So we're going to take our two parts, x plus 2 set it equal to 0, and x minus 5 equals 0, and we'll just solve. Okay, minus 2, x equals negative 2. And, hi Miss Hesse, plus 5, x equals 5. Okay, now, easy, right? But what does it mean? Super easy. What does it mean? Okay, so here, first of all, it is an x-intercept at negative 2. Do you see that? And it's an x-intercept at 5. Does that make sense? Now there's a bigger piece. Now I want you to think about this. Super easy. See where my pin is? Everybody watching? Everybody looking? See where my pin is? If x were 5, right? If x were 5, I put a 5 right in here. What's 5 minus 5?
0.
And then 0 times this is still 0. Does that make sense? So 5 makes the whole problem be 0. So 5's got to be an answer. Does that make sense? If negative 2 were here, think about this. If negative 2 right here, negative 2 plus 2 is what?
0.
And 0 plus whatever this is still 0. So these are the two answers that make it equal to 0. They're also x-intercepts. It's easy, isn't it? Okay, so how about number 2? What do you think the answers are? Well, let's do our little mini equations. So I do our mini equations. So I'm going to do my mini equations. I'm going to go on x plus 5 equals 0 and a 2x minus 1 equals 0, right? And I'm just going to solve. It's really pretty easy. Okay, we're going to go minus 5. One of my zeros is negative 5. Plus 1. I got a 2x equals 1. Divide by 2. My other 0 is 1/2. Okay? These are my zeros. If I were to plug either one of them back in, it would make it 0. Plus, they're also x-intercepts. I'll say it again. These are my answers. If I plugged either one of these back into the equation, it would make the problem 0. These are also x-intercepts. Okay. Example 3. Now, example 3 is a little weird because there should be two answers. And there will be two answers, but it's going to be the same answer twice. So, mini equations. 2x minus 6 equals 0 and 2x minus 6 equals 0. Now, of course, you're thinking, Mr. Davies, do we really have to solve it again? No. but I want to show you there will be 2 answers. There really are, okay? So plus 6, 2x equals 6, divide by 2x is 3, and x is 3 over here. So it happens twice, the same answer twice, but you still got 2 answers. Even though it's the same answer, you still got it twice, okay? So this is what we call a double root or a double zero, okay? This one looks like this on a graph. Graphically, and we don't have to know this yet, but I'm trying to set us up for later. Looks like this, where it's supposed to go through twice, but just touches it in one spot. Makes sense why it'd be counted twice? Okay. Okay, number 4. Oh man, I see 3 x's. 3 answers. 3 answers? Okay, so we should have 3 answers because I've got 3 x's. So again, let's set up our mini equations, right? I'm going to go 3x equals 0 and 2x plus 5 equals 0 and 2x minus 5 equals 0, okay? Okay, divide by 3, divide by 3. 0 divided by 3 is 0. So one of my answers is 0. Minus 5, 2x equals negative 5, right? Divide by 2, divide by 2. Another answer is negative 2.5. My third answer, same thing, plus 5, 2x equals 5. Divide by 2, and I get x equals a positive 2.5. And I got 3 answers. Okay, 3 answers. A graph of this would look something like this. You don't have to know this yet. You don't have to know this, but a graph of this would look something like this. It would look like this. Yeah. A graph of this one would look something like this, where it goes through at negative 2.5 here, 0, and positive 2.5. We don't have to know this yet, but I like to give you a little insight of where we're going, okay? Because this is actually pretty easy to do, but what does it mean? What it means is you're finding the x-intercepts, and that's where the height is 0. These are the values that make it 0, okay? That's what we're doing, okay? Are you ready to turn the page? All right. Example 5. Common factoring. Okay, we just talked about common factoring, right? So in example 5, there will be 2 answers. There will be 2 answers, but we need our mini equations first. So to get my mini equations, let's factor. So to get our mini equations, let's factor. Okay, in factoring, we just briefly talked about factoring, right? So if I have to factor, I take a look at both my 5x squared and my 10. I say, okay, first of all, let's look at the numbers. Look at the numbers. Okay, 5 and 10. 5 and 10. What's the biggest number that divides into both? 5 and 10. 5. You guys agree with Cameron? 5 goes into 5, and 5 goes into 10, so common factor out the 5, right? X squared x. How many x's do they have at least in common? 1x. We take out that 1x, okay? So then, what's left over? So if I take a 5x out of a 5x squared, take a 5 and an x out, what's left over? Just an x, right? Plus 5 goes into 10 2 times equals 0. And you can go back and double check. So I'm not sure if I'm right, but it should. There's my 5x squared and my 10x, right? So now I have my mini equations, right? I've got my mini equations. I've got my mini equations. So now I can set it up, okay? Got my mini equations. So I'll go 5x equals 0 and x plus 2 equals 0, right? And just solve. This is actually pretty easy, isn't it? Divide by 5, x is 0. That's one of my zeros. Minus 2, x equals negative 2. That's my other 0. Okay, thumbs up. Pretty easy, isn't it? Okay. Example 6. To do example 6, I'm going to put in this invisible number to help me out. There's an invisible 1 there. You guys agree? There's an invisible 1. And that's going to help me do this problem, okay? So, what's the biggest number they have in common?
3.
Just 1. Just 1. Yeah, you can't really divide 1 by 3 without
You're
getting a
right.
fraction, right? But we can take a 1. And how many x's do they have at least in common? 1. So let's see what happens. I'm going to have a 3x minus 1. You have to have the 1 there. You have to have the 1 there. Because you have to be able to go 3x squared and a minus 1x, right?
Could you do it 3x on the outside and then put 1x or x inside?
If I did a 3x
Like
on the
that?
outside, yeah, if you did that, Isaac, you'd have to have a 1/3
Oh,
here.
1/3. Okay.
Okay, and that's kind of messy, right?
Yeah.
You agree? Because then that times that would equal 1.
Yeah.
So if you did this times this in yours, right? This times this gives me a 3x. That's not a
Okay.
3x. That makes sense?
Yeah.
Okay, now, let's go ahead and do our mini equations. We have a 1x equals 0 and a 3x minus 1 equals 0, right? Divide by 1, divide by 1. Well, I don't really need to. One answer is 0. Plus 1, plus 1. 3x equals 1. Divide by 3, and you get 1/3, which you would have gotten the 1/3 from this, wouldn't you? So you weren't wrong when you did the 1/3. It's just you just don't want a fraction, okay?
Yeah.
Now, does that seem pretty easy?
Mm-hmm.
Let's look at our journals real quickly, okay? And then it should be a day.